Well, I don't generally have adequacy issues, but geez, this is a big screen. Yeah, that screen on the right is a pretty big screen. That's a 27-inch screen. I just got this monitor in from a fellow tweaker called Albert, and it's broken. It's a UHD screen. It's a 4K screen, and from what I understand, he got this for promotion purposes or something. I kind of forgot. Somewhere along the line, it broke down, and because he didn't really properly buy it, there's no real warranty on it, even though it's a brand new screen. So he really would like this to be fixed, which is exactly what we're gonna do. And the issue with the screen is I've got it currently plugged in, power strip is on, and it just doesn't power up at all. So it's clearly a power supply failure. This screen has actually been at a repair shop for like 3 months. They couldn't figure out what was wrong there. And it was clearly opened by some kind of idiot. You can see here, they tried to use a screwdriver to wedge open the plastic from the rest. This is just inexcusable, especially for a modern computer electronics servicing center. These things, they're either called plectrums or like guitar plectrums or just plastic tools. Always use these to lever open these casings. Alright, I just opened up the screen, and do you notice anything? I haven't done anything yet. Do you notice anything wrong about this? Possibly. No? Let's just zoom in here. Notice anything? Notice anything now? Or now? I think I found the problem. That looks pretty exploded to me. That is a mess. Oh man. There is clearly, let me just get in a bit closer. What I'm seeing here is there's like a bit of trace that has been blown away here. There's a small, I guess a small resistor blown off. Maybe this one as well. This doesn't really look too good, although this could be just carbonization. But definitely the epicenter of damage is here. So let's just look at the other side of the board, what that could be. Well, first, before we start the repair, let me just gush over the beauty of this board. This is a really well laid out board and actually has very high quality components all around, pretty much. Here we have the input. We've got a proper, we've got an MOV. We've actually got a nice fuse. This seems to be a ceramic filled fuse. A fairly elaborate EMI rejection stage. Nice heat sunk diode bridge. This screen doesn't consume that much power, so I wouldn't have expected the diode bridge to actually need cooling, but it's nice that they have it. Then they have what seems like are those diodes? It's fairly hard to say. Yeah, those are diodes. So they have a PFC stage. This would be the PFC choke. I would guess these would be this is a diode, so this will have to be the PFC switch. They have a couple of diodes here as well, so it's probably critical mode. And then they have 2 transistors as far as I can tell. So maybe, let me see, because they have 2 transistors here and a capacitor. This is a very conspicuous capacitor here, just at this core. I think this is an LLC resonant converter, a half bridge LLC resonant. and they probably, because they have this nice planar core, these cores don't have a lot of, they have very good coupling, so they don't have a lot of extra inductance. So I would have expected an extra inductor as well, but it's not there. This seems to be a resistor. I still think this is an LLC resonant. And they have, they just have diodes for rectification here, so that's not too impressive, unfortunately. And then here they have another, what seems like a full bridge stage for the LED drivers, and this is also just a beautiful thing. Here, this is actually a hard, like ceramic type material. So what they have here is just constant current LED drivers, but they have this plate of mu metal on top to reduce, because this is probably switching at like extremely high frequencies. So this is kicking out a lot of EMI, and they have this block on top to shield it. I just really like this kind of stuff. Yeah, and otherwise that's pretty much it. They have helpfully provided us with pinning. And apparently this runs on 13 volts. Maybe it's just A13V. Let me, oh wait. They have a better thing here. So it's, yeah, it's 12.8 volts, 4 amps. And then they have 41.82 volts at 110 milliamps. It's not a lot. Like this is, altogether, this is just about 80 watts. 80 watts in. So I wouldn't have expected them to use LLC, because LLC is quite a bit more expensive. Well, anyway, the only thing that I can really fault them for is that the soldering on these connections here is pretty bad. But like overall, I don't really have to go into detail. We're doing a repair video, but it's just a very nice board, nice quality components. I'm very impressed. Yeah, so the failed component is definitely this transistor. It's a MOSFET, and it basically measures a dead short across all the terminals. Well, after much cleaning, it actually seems like the controller is completely fine. I don't see any blowout holes or discolored traces or anything. It seems like the damage is completely localized to the MOSFET, and only the single MOSFET. The other one is fine. Also interesting to see is that we have an actual Fuji Electric, which is not a very common brand to see, LLC controller. It's a Fuji Electric 6C14734. I can't really find any data sheets for it, and it's definitely not going to be easy to source. But yeah, it seems like the two MOSFETs actually have the same kind of drive circuit. I guess the Fuji Electric thing has a built-in bridge driver, because one of the bridge's legs is floating at like 400 volts. So probably has that's probably why it's good at absorbing the high voltage impact. And I will just have to replace the MOSFET and maybe some of the resistors. Well, I've replaced the two transistors, both of them. They both didn't measure very well. I've replaced the fuse with an identical one. And also, on the bottom side, you can see, I'm just getting close. Like that leg of the transistor, I had to bend it over because the copper was blasted away. And I also had to touch up some of the resistors, actually replacing the 100 ohm 1206 resistor there and another resistor. I used a 0402 there instead of the 0603, I think that was there, but shouldn't really matter that much. I've tested all the other components, like there is a diode here. This is just a fairly generic push-pull driver circuit. And I tested the capacitor here, the ceramic, and everything seems to test okay. So I think everything has been fixed. Now, just as a precaution, I've hooked up the board to my isolation transformer, so that in case it does still have like a short circuit or something goes wrong explosively, it doesn't trip my breakers. I've got some stuff on that I don't want to shut off, and there's not too much energy that can flow into here, because like even with the fuses intact, all the fuses on here are slow blow, so it could get quite nasty if something flames out. So yeah, let's flip the switch and see if it explodes. And it seems to be fine. That's kind of boring. There are some capacitors here. Only measuring fairly low. 100 millivolts. I actually found another broken resistor, which I replaced. So let's try again. It might explode now. Jeez, this is not a very exciting episode, isn't it? Let's see if there is an output voltage now. Still nothing significant. Well, I've been probing around a bunch on the PCB. I've actually found the datasheet for the controller. It's a Fuji Electric 6A01N, which is, as I thought, an LLC resonant controller. It has a standby input that seems to be okay. It has a power supply input which seems to be okay, but none of the outputs are doing anything, like not even a single pulse. Essentially just nothing going on. So I think the controller is just completely busted, which makes sense. It was quite a big explosion. I would have kind of hoped that the controller would have survived, but something is definitely wrong there, and there's basically nothing else active around that could disturb this. So I'm going for that. I found the controller on eBay, bought it, and we'll replace it in the next clip. I'm a rebel. Yeah, so if you're ever interested in like a decent small series production SMD workflow, one of these, this is a paste dispenser, is very handy. So I will apply some paste, not a lot, to all the pads. Yeah, and this is really why I love the SMD soldering process so much. It's just placing components, kind of sort of dabbing some solder paste here and there, doesn't have to be exact, and then just pointing a hot air gun at the component. And it solders itself, it positions itself mostly. It's just so easy. It's so much better than through-hole soldering. So here's the same situation as before. I have my completely non-flammable stack of component packages and a nice cardboard box with more cardboard in it and expensive electronics. I have something that might explode connected to my transformer, and I'm going to turn on the power and see if it explodes. Unfortunately, it didn't. Let me just check some voltages. Nope. I'll just put this here. I am getting 12.96 volts, which means that I'm pretty sure that this has been fixed. So I'm going to build it into the monitor and turn it on, and maybe we'll see some magic. By the way, guys, this here, where the explosion happened, there is some soot here, and it's really important to know that soot is carbon and carbon is conductive. So whenever something like that happened, it's not just for aesthetic reasons, but actually for functional reasons, that you should really just take some IPA and thoroughly clean it. And you'll see there's quite a lot of conductive material that came up. So, have we fixed it? I see an LED coming on. Oh my god. Yep. It's fixed, guys. Well, unfortunately, even though it's a very nice monitor, it's not mine. I have to send it back. Such a shame, it's a really nice monitor. Anyway, I hope you like this troubleshooting and repair video of a 4K Samsung screen. See you next time.